Hello, welcome to the fourth Jedi video. This is from week 2B, and we're looking at problem 1 on Wiley Plus, which states, in 2.2 seconds, 1.9 times 10 to the 19th electrons pass a certain point in the wire. What is the current I in the wire? So, electric current is the measure of how much electric charge flows past a specific point in a circuit at every second. So, I'm going to start by defining a few variables and their SI units that we have that are useful for this problem. So we have I, which stands for current, and current is the rate, again, at which electric charge flows through a conductor. So the SI unit used for current is amperes, which are A, or represented by an A, I should say, and they're also equivalent to coulombs per second. And then we also have Q, which is representative of electric charge, and the SI units are coulombs. T, of course, stands for time, and SI units for time are seconds here. N is the number of electrons, and it has no SI units. And then lastly, E is elementary charge, which is represented by coulombs as well. Alright, so to solve this problem, we're going to be looking at two primary equations, and the first one is the charge quantization equation, which is seen as Q equals N times E, and then these variables we have all defined here, so that's at our disposal. And then the second equation we're going to be using is the electric current equation, which is I equals Q over time. So we're going to start off by calculating the total charge first, and we have to substitute the number of electrons which is given to us. So it's 1 times 10 to the 19th, and that's going to be our N. 1.9 times 10 to the 19th. And then the constant, which is our elementary charge, which we know is 1.602 times 10 to the negative 19th electron. So then we're going to use this first equation and multiply those up by each other. And because we're multiplying, these cancel out, and we are left with 1.9 times 1.602 coulombs, which ultimately results in 3.0438 coulombs. Alright, and then for our second step, now that we have this, we have to calculate the current, which is I. So we have to substitute the total charge that we just found here. Try not to show the answer. And the given time, which is 2.2 seconds. So let's plug that into our other equation. Q over time, which equals 3.0438 coulombs over our time is 2.2 seconds. And I equals 1.3835 amperes. Alright. And now we're left with this. But sometimes when we plug it into Wiley Plus, it gets a little finicky, so I like to round up. And it looks like that checks out. I rounded it up to 1.4. And now let's move on to our next problem. Alright, so moving on to the next problem we have, which is problem number 2 on the Wiley Plus program. It states that which one of the following graphs correctly represents Ohm's law, where V is the voltage and I is the current. So we know that Ohm's law describes a linear relationship between electrical voltage and current. So if you increase the voltage, then that means that the current that flows through the resistor will increase by the same amount. So given that we know this, then if there's no voltage, which means that if we have V equals 0, then therefore I must also equal 0. And graph C is the only graph that shows that straight upward slope of a line that starts from an origin of 0, 0. So this is graph C here, and you can see it starts here, and then we have that upward trend, so that proves those definitions correct. But to give a few definitions, we know that V is the voltage, and the SI units for voltage are in volts, which are represented by the V. And then we recognize that I stands for current, which we defined in our previous problem, and the SI units are amperes, and R is resistance, which are measured in ohms, which kind of look like this. That was a terrible drawing of the character, but anyways. So these definitions, though, are seen in our equation, the V equals I times R, but in order to solve this problem, we're not really actually doing any mathematical work. It's more like reasoning through it with our knowledge that we have already. So given the information that I went over already, see that graph C would be the correct answer for this problem. And let's make sure that it is correct and it checks out.